Good morning, student. Today we are going to see that synthetic application of acetoacetic ester in the synthesis of adipic acid. So, acetoacetic ester is first treated with your sodium ethoxide. Since sodium ethoxide is a mild base, it takes away one of the proton and ethyl alcohol molecule basically goes out in the reaction, and this H is basically replaced by your Na. So see here, one of the hydrogen on this active methylene group is replaced by sodium. Now two molecule of this monosodio derivative is reacted with your ethylene dibromide. During this reaction, this NaBr goes out, so there is two molecule, therefore two NaBr goes out. One is from here, another is from, and all the molecule club together, that is all this portion join on this CH2 and all this portion is join on this CH2. When this compound is treated with concentrated KOH, so two molecule of acetic acid is formed. Two molecule of ethyl alcohol in the reaction goes out as a byproduct, and the main product which is formed in the reaction is adipic acid. Now just carefully see this structure. In this structure, the ethylene group is denoted by blue color pen, which is basically come from your ethylene dibromide, and all the group, all other part of the molecule is written with red pen, which is basically coming from your monosodio derivative. When we add concentrated KOH, so take the help of 4 water molecule to write adipic acid. So break down one of the water molecule as HOH and draw this line and break this bond which is present between this carbon and this carbonyl group. So this methyl, C double bond O and OH from water molecule. So that's why this water OH in this acetic acid molecule is written with blue pen, which tell us that this OH basically coming from your water molecule. Also in adipic acid structure, just see the hydrogen which is written by red pen, it is already present on your carbon, and one of the hydrogen which is written by blue pen, it is coming from your water molecule. In ethyl alcohol, H is written with blue pen, which tell us that this hydrogen is also coming from your water molecule. So this is the overall synthesis of adipic acid by acetoacetic ester. Now how we are going to synthesize alpha beta unsaturated acid by using acetoacetic ester? So we know that these two hydrogen in acetoacetic ester are active hydrogen. When this acetoacetic ester is reacted with aldehyde, so basically these two hydrogen and this oxygen forms water molecule, means it is a condensation reaction, and this part is joined with your acetoacetic part with a double bond. So important thing, I write this molecule with a red pen. This part is basically coming from your aldehydic group. Again add concentrated KOH. As we know that whenever we add concentrated KOH, one molecule of acetic acid and one molecule of ethyl alcohol goes out as a byproduct, and acid is formed. But when this acid is formed, this C take one of the hydrogen from water molecule and C double bond OH is from your this carbonyl group, which is basically the part of your ester group. If R is equal to methyl, means if this compound is acid aldehyde, so just replace R here with CH3. We got product CH3CH double bond CH C double bond OH, and it is known as protonic acid. If R is C6H5, that is if this is a this molecule is benzaldehyde, then we got just replace R here with C6H5 CH double bond CH COOH. It is the basically a structure of cinnamic acid. So now we are going to see how acetoacetic ester is used for the synthesis of ketones. If acetoacetic ester is treated with mild base, that is sodium ethoxide, one of the hydrogen goes away and sodium comes here. If we add here Rx, that is aldehyde, that is alkyl halide, so NX goes off and R is substituted in the place of Na. So RCH C double bond O Me. Now the very much important step is happening here. A very much important reagent. Just see here, we write dilute KOH, not concentrated KOH. If we write here concentrated KOH, then product is different. But when we write dilute KOH, so previously we see that when we add dilute KOH, we got ketone molecule. Just see here, dilute KOH gives us ketone basically, and one of the carbonyl group get decarboxylated and C2H5 comes as a byproduct. So same thing is happening here. Out of this two carbonyl group, a carbonyl group which is the part of your ester group get decarboxylated, gives you CO2. This part give you ethyl alcohol, and all the remaining part going to be a form a ketone. This part basically going to be a form ketone, because one of the hydrogen from water comes on this carbon. So we got RCH2 C double bond O Me. If R is equal to methyl here, the product is formed here is CH3 CH2 C double bond O Me, that is ethyl methyl ketone. If R is ethyl, in step number 2, if we add ethyl chloride, so product which is formed is CH3 CH2 CH2 C double bond O Me, that is methyl propyl ketone. Just replace R here. If R is equal to CH3 C double bond O, means if we add acetyl chloride in your first step, so just replace R here with CH3 C double bond O. So product is CH3 C double bond O CH2 C double bond O Me, that is acetyl acetone. It is also a beta diketone compound. Now preparation of 1,4-diketone, that is acetonyl. Just see the difference between these two names. It is acetyl and it is acetonyl acetone. It is a basically 2,4-diketone, and acetonyl acetone is basically 1,4-diketone. If we take acetyl ester of if we take acetoacetic ester, react it with mild base, one of the proton goes away, sodium comes here. If we take two molecule of this monosodio derivative and reacted with iodine, so NaI, two molecule of NaI goes off, and this whole two molecule join with each other. And if we reacted this compound with the dilute KOH, so two CO2 molecule goes out, and we got Me C double bond O CH2 CH2 C double bond O Me, that is acetonyl acetone. It is also known as hexane 2,5-dione. Just give the numbering from one end, 1 2 3 4 5 6. Since it is a 6 carbon atom chain, that's why hexane is here. At 2 position and 5 position there is ketone group, that's why here is 1, that is for ketone. Since 2 ketone groups are there, that's why di comes here, and the 2,5 denotes the position. Now we are going to see preparation of heterocyclic compound from acetoacetic ester. First we are going to see preparation of methyl isoxazolone. If we take acetoacetic ester and react it with hydroxylamine, what is the formula of hydroxylamine? It is NH2OH. So 2 hydrogen from nitrogen and oxygen, which is the part of your carbonyl group, undergo condensation. So minus H2O goes from here and ETOH goes from here. So all the molecule club together. So we got CH2CMe, double bond N, single bond O, single bond C double bond O. This is known as methyl isoxazolone. It is the heterocyclic compound. What is heterocyclic compound? If you are in your ring structure, if there is atom other than carbon atom is present, then that compound is simply known as heterocyclic compound. Now we are going to see preparation of 4-methyl uracil. Whenever you write this reaction, you have to write enol form of this compound, that is acetoacetic ester. How enol form of this compound can be written? जब shift one of the bond, which is the part of double bond in between these two carbon atom, because of that one of the hydrogen from this CH2 shifted on oxygen, so it is basically a enol form. When it is reacted with urea, so since urea have NH2 group, one of the hydrogen from this NH2 and OH from your enol form of acetoacetic ester undergoes condensation, so water molecule goes away and ETOH from here goes away. So we got the structure like this, that is NHCMe CH C double bond O NH C double bond O. It is known as 4-methyl uracil. always start numbering from this nitrogen. So methyl comes at 4th position. So it is 4-methyl uracil. In the next class we are going to see carbohydrate. Thank you very much.